Good evening. Rahul Jha welcomes you. Today I will be talking about all possible modes of energy production, energy storage, or energy conservation, listed alphabetically. These all sources are accepted as legitimate or have been proven to be tappable. So let's start. So first is atomic energy. Atomic energy or energy of atoms is energy carried by atoms. The term originated in 1903 when Ernest Rutherford began to speak of possibility of atomic energy. Well popularized the phrase splitting the atom before discovery of atomic nucleus. So atomic energy includes nuclear binding energy, energy required to split a nucleus of an atom, nuclear potential energy, the potential energy of the particles inside an atomic nucleus, nuclear reaction, a process in which nuclei or nuclear particles interact, resulting in products different from initial ones. See also nuclear fission and nuclear fusion, that is related to nuclear reaction. Radioactive decay, the set of various processes by which unstable atomic nuclei forms subatomic particles, gives away some radioactive particles, decay particles, or they emit some radioactive decay. The energy of interatomic or chemical bonds which holds atom together in compounds. This is at binding energy or atomic energy. So atomic energy is a source of nuclear power which uses sustained nuclear fission to generate heat and electricity. It is also the source of explosive force of an atomic bomb. That is, it might be used during peace as well as during a war. So it is quite useful and too dangerous sometimes. Now, one form of energy is Banki turbine. A cross-flow turbine, Banki-Mitchell turbine, is a water turbine developed by Australian Anthony Mitchell. Next is battery associated with electricity. A battery is a source of electric power consisting of one or more electrochemical cells with external connections from powering electrical devices. When a battery is supplying power, its positive terminal is the cathode and the negative terminal is anode. The terminal marked negative is a source of electrons that will flow through an external circuit to the positive terminal. When a battery is connected to an external electric load, a redox reaction converts high energy reactants to lower energy products, and the free energy difference is delivered to the external circuit as electrical energy. Historically, the term battery specifically referred to as device composed of multiple cells. However, the usage has evolved to include devices composed of single cell at present. Bioalcohol. Various alcohols are used as fuel for internal combustion engines. The first four alcohols are methanol, ethanol, propanol, and butanol. These are of interest as fuels because they can be synthesized chemically or biologically, and they have characteristics which allow them to be used in internal combustion engine. Biodiesel. Biodiesel is a form of diesel fuel derived from plants or animals and consisting of long chain fatty acids esters. It is typically made by chemically reacting lipids such as animal fats, tallow or soybean oils, or some other vegetable oil also, with an alcohol producing a methyl or propyl ester by process of transesterification. So transesterification is a process by which methyl, ethyl and propyl is processed. Unlike the vegetable and waste oils used to fuel converted diesel engines, biodiesel is a drop in biofuel. Meanwhile, it is compatible with existing diesel engine and distribution infrastructure. However, it is usually blended with petrodiesel, typically to less than 10%, since most engines cannot run on pure biodiesel because with modification there can be some problem. Biodiesel blends can also be used as heating oils. Now 100% biodiesel is referred to as B100, 20% biodiesel and 80% petrodiesel is labeled B20. Similarly, 10% biodiesel is called B10, 7% biodiesel is called B7, 5% biodiesel is called B5, and 2% biodiesel is called B2. Biodiesel production. Biodiesel production is the process of producing the biofuel biodiesel through the chemical reaction of transesterification and esterification. This involves a vegetable or animal fats and oils being reacted with short chain alcohols, typically methanol or ethanol. The alcohols used should be of low molecular weight. Ethanol is the most used because of its low cost. However, greater conversation about this is that greater conversion into biodiesel can be reached using methanol. Although the transesterification reaction can be catalyzed by either acids or base, the base catalyzed reaction is more common. This path has lower reaction times and catalyst cost than those acid catalysis. However, alkaline catalysis has the disadvantages of high sensitivity to both water-free fatty acids present in the oil. Biofuel. Biofuel is a fuel that is produced over a short time span from biomass, rather than by the very slow natural process involved in the formation of fossil fuels such as oil. Biofuel can be produced from plants or from agriculture, domestic or industrial bio-waste. Biogas. Biogas is a gaseous renewable energy source produced from raw materials such as agricultural waste, manure, municipal waste, plant materials, sewage, green waste, wastewater and food waste. Biogas is produced by anaerobic digestion with anaerobic organisms or methanogens inside an anaerobic digesters, biodigesters or bioreactors. The gas composition is primarily methane and carbon dioxide and may have some amounts of hydrogen sulfide also and moisture. The gases methane and hydrogen can be combusted or oxidized with oxygen. This energy released allows biogas to be used as fuel. It can be used in fuel cells and for heating, such as cooking. It can also be used in gas engine to convert the energy into gas, into electricity and heat. Biomass. Biomass is a term used in several contexts. In the context of ecology, it means living organisms. And in the context of bioenergy, it means matters from recently living but not dead organisms. In the later context, there are variations in how biomass is defined. example only from plants or from plants and algae or from plants and animals. The vast majority of biomass used for bioenergy does come from plants. Bioenergy is a type of renewable energy with potential to assist with climate change mitigation. Bio-nano generator. Research is going on to use nanowires and other nanostructured materials with the hope to create cheaper and more efficient solar cells than are possible with conventional silicon solar cells. It is believed that the invention of more efficient solar energy would have a great effect on satisfying global energy needs. Now, bitumen. Bitumen is a sticky black, highly viscous liquid or semi-solid form of petroleum. Before the 20th century, the term asphalt was used for this. Now, primary use of bitumen as in that can be seen in road construction, where it is used as glue or binder mixed with aggregate particles to create asphalt concrete. Its other main use are bituminous waterproofing, including production of roofing felt. Now, in material sciences and engineering, the terms asphalt and bitumen are often used interchangeably. Breeder reactor. A breeder reactor is a nuclear reactor that generates more fissile material that it consumes. Then reactors can be fueled with more commonly available isotopes of uranium and thorium, such as uranium-238, thorium-232, as opposed to the rare uranium-235, which is used in conventional reactors. These materials are called fertile materials since they can be bred into fuel by these breeder reactors. Breeder reactors achieve this because their neutron economy is high enough to create more fissile fuel than they use. Now, bubble fusion. A nuclear fusion reaction hypothesized to occur an extreme form of acoustic cavitation. This is still under research. And now, coal. Coal is a combustible black or brownish black sedimentary rock formed as rock strata called coal seams. Coal is mostly carbon with variable amounts of other elements, chiefly hydrogen, sulfur, oxygen and nitrogen. Coal is a type of fossil fuel formed when deep plant matter decay into peat and is converted into coal by heat and pressure of deep burial over millions of years. Coal mining. Coal mining is a process of extracting coal from the ground or from the mine. Coal is valued for its energy content, and since the year 1880 it has been widely used to generate electricity. Steel and cement industry also use coal as fuel for extraction of iron from iron ore. And there are many other uses. Cold fusion. Cold fusion is a hypothesized type of nuclear reaction that would occur at only room temperature. It would contrast starkly with hot fusion that is known to take place naturally with stars. And artificially in hydrogen bombs and fusion reactors under immense pressure and temperature of million degrees. And so cold fusion is fusion that can happen at room temperature. There is currently no accepted theoretical model that would allow cold fusion to occur. Combustion. Combustion or burning is a high temperature exothermic redox chemical reaction between a fuel and an oxidant. Usually atmospheric oxygen that produces oxidized, often gaseous products in a mixture termed as smoke. Combustion does not always result in fire. because a flame is only visible when substance undergoes combustion, vaporizes. But when it does, a flame is characterized indicator of reaction. Compound turbine. Compound turbine is a steam turbine in which there are two casings, high pressure casing and a low pressure casing, operating in concert to extract work from single source of steam. The steam is partially expanded in the high pressure casing, then exhausted to the low pressure casing. Compressed air energy storage. Compressed air storage is a way to store energy for the later using. Compressed air. At a utility scale, energy generated during periods of low demands can be released during peak loads periods. Concentrated solar power. Concentrated solar power, also known as concentrating solar power, concentrated solar thermal, systems generate solar power by using mirrors or lens to concentrate a large area of sunlight into a receiver. Electricity is generated when the concentrated light is converted to heat, solar thermal energy. This drives the heat engine, usually a steam turbine connected to the electrical power generator, or power a thermochemical reaction. Deep lake water cooling. Deep lake water source cooling or deep water air cooling is a form of air cooling for process and comfort space cooling, which uses a large body of natural cold water as a heat sink. It usually uses water at 4 to 10 degrees centigrade Celsius drawn from deep areas within the lakes, oceans, aquifers, or river, which is pumped through one side of heat exchanger. On the other side, the heat exchanger cooled water is produced. Diesel. Diesel fuel, also called diesel oil or historically heavy oil, is any liquid fuel specifically designed for use in diesel engine. A typical of internal combustion engine in which fuel ignition takes place without a spark as a result of compression of the inlet air and then injection of fuel. Therefore, diesel fuel needs good compression ignition characteristic. Electrical grid. An electrical grid is an interconnected network for electricity delivery from producers to consumers. Electrical grids vary in size and can cover whole country or continents. It consists of power stations, often located near energy and away from heavily polluted area. Electrical substation to step voltage up or down. Electrical power transmissions to carry power long distances. Electrical power distribution to the individual customers where voltage is stepped up or down, again as per requirement. Energy tower. Energy tower is a device for producing electrical power. The brainchild of Dr. Philip Carlson. Energy towers spray water or hot air at the top of tower, making the cooled air fall through the tower and drive a turbine at the low tower's bottom. External combustion engine. An external combustion engine is a reciprocating heat engine where a working fluid contained internally is heated by combustion in an external source through the engine valve or heat exchanger. The fluid then, by expanding and acting on the mechanism of the engine, produces motion and usable work. The fluid is then dumped or cooled, compressed and reused. In these type of engines, the combustion is primarily used as a heat source and the engine can work equally well in other types of heat sources. Fischer-Tropsch process. This process is a collection of chemical reaction that converts a mixture of carbon monoxide and hydrogen known as syngas into liquid hydrocarbons. These reactions occur in the presence of metal catalysts, typically at a temperature of 150 to 300 degrees centigrade and pressures of one of the several tenths of atmosphere. The Fischer-Tropsch process is an important reaction in both cold liquefaction and gas to liquid technology for producing liquid hydrocarbons. Flywheels storage. The flywheel is a mechanical device which uses the conservation of angular momentum to store rotational energy, a form of kinetic energy proportional to the production of its moment of inertia and the square of rotational speed. In particular, assuming the flywheel moment of inertia is constant, flywheel with fixed mass and second moment of area revolving about some fixed axis, then the stored energy is directly associated with the square of its rotational speed. Fossil fuel. A fossil fuel is hydrocarbon containing materials such as coal, oil, and natural gas, formed naturally in the earth's crust from the remains of dead plants and animals that is extracted and burned as fuel. Fossil fuel may be burned to provide heat for use directly, such as cooking or heating, to power engines such as internal combustion engine in motor vehicles, or to generate electricity. Some fossil fuels are refined into derivatives such as kerosene, gasoline, and propane before burning. The origin of fossil fuels is the anaerobic decomposition of buried dead organisms containing organic molecule created by photosynthesis. The conversion of these materials to high carbon fossil fuels typically requires geological process of millions of years. Fossil fuel power station. A fossil fuel power station is a thermal power station which burns a fossil fuel such as coal or natural gas to produce electricity. Fossil fuel power stations have machinery to convert the heat energy of combustion and mechanical energy, which then operates an electrical generator. The primary move may be steam turbine or gas turbine, or in small plants, a reciprocating gas engines. All plants use the energy extracted from the expansion of hot gases, either steam or combustion gases. Although different energy conversions methods exist, all thermal power stations conversions methods have their efficiency limited by the Carnot efficiency and therefore produce waste heat. Fuel. A substance used as source of energy, usually by heating, produced by combustion. A fuel is any material that can be made to react with other substance so that it releases energy as thermal energy or to be used for work. The concept was originally applied solely to those materials capable of releasing chemical energy, but since it has also applied to other sources of heat energy such as nuclear energy and nuclear fusion. The heat energy released by reaction of fuels can be converted into mechanical energy via a heat engine. Fuel cell. A fuel cell is an electromechanical cell that converts the chemical energy of the fuel, often hydrogen, as an oxidizing agent, often oxygen, into electricity through a pair of redox reaction. Fuel cells are different from most batteries in requiring a continuous source of fuel and oxygen, usually from air, to sustain the chemical reaction, whereas in a battery the chemical energy usually comes from substances that are already present in the battery. Fuel cells can produce electricity continuously for long and as long as fuel and oxygen is supplied. Fuel efficiency. Fuel efficiency is a form of thermal efficiency, meaning the ratio of effort of result of process that converts chemical potential energy contained in the carrier into kinetic energy. Fusion power. Fusion power is proposed form of power generation that would generate electricity by using heat from nuclear fusion reaction. In a fusion process, two lighter atomic nuclei combine to form a heavier nucleus while releasing energy. Devices designed to harness this energy are known as fusion reactors. Research into fusion reactors began in 1940s, but as of 2023, no device has reached net power till now. Gas turbine. The gas turbine, also called combustion turbine, is a type of continuous flow internal combustion engine. A main parts common to all gas turbine engines form the power producing part known as gas generator or core and are in direction of flow. A rotating gas compression, a combustor, a combustion driving turbine. Gasohol. Several common ethanol fuel mixtures are in use around the world. The use of pure hydrous or anhydrous ethanol in internal combustion engine is the only possible if the engines are designed or modified for that purpose and used only in automobiles, light duty trucks and motorcycles. Anhydrous ethanol can be blended with gasoline for use in gasoline engines, but with high ethanol content only after engine modification to meet increased fuel volume. Since pure ethanol contains only 2/3 or BTU of an equivalent volume of pure gasoline. High percentage of ethanol mixture are used in some racing engines application as the very high octane rating of ethanol is compatible to very high compression ratio. Geothermal exchange heat pump. A ground source heat pump, also geothermal heat pump, is a heating cooling system for building that uses the type of heat pump to transfer heat or from the ground, taking advantage of relative constancy of temperature of earth through the seasons. Ground source heat pump or geothermal heat pumps, as they are commonly termed in North America, are among the most energy efficient technology for providing HVAC and water heating using fair and far less energy than can be achieved by burning a fuel in a boiling or boiler furnace or by use of resistive electric heaters. Geothermal heating. Geothermal heating is a direct use of geothermal energy for some heating applications. Humans have taken advantage of geothermal energy and geothermal heat this way since the long back. Approximately 70 countries made direct use of total 270 PJ of geothermal heating in 2004. As of 2007, 28 GW of geothermal heating capacity is installed around the world, satisfying 0.07% global primary energy consumption. Thermal efficiency is high since no energy conversion is needed, but capacity factor tend to be lower, around 20%, since the heat is mostly needed in the winter. Geothermal energy originates from the heat retained within the earth since the original form of the planet, from radioactive decay of the mineral, and from solar energy absorbed at the surface. Most high temperature geothermal heat is harvested in region close to tectonic plate boundaries, where volcanic activity rises close to surface of earth. In these areas, ground and groundwater can be found with temperature higher than the target temperature of the application. However, even cold ground contain heats below 6 meters. The undisturbed ground temperature is consistently at the mean annual air temperature, and heat can be extracted with the ground source heat pump. Geothermal power. Geothermal power is electrical power generated from geothermal energy. Technology that is used include dry steam power station, flash steam power station, and binary cycle power station. Geothermal electricity generation is currently used in 26 countries, while geothermal heating is in use in 70 countries. Grid energy storage. Grid energy storage, also called large scale energy storage, is a collection of methods used for energy storage on a large scale within an electrical power grid. Electrical energy is stored during times when electricity is plentiful and inexpensive. Sources such as renewable electricity from wind power, tidal power, and solar power, or when demand is low, are later returned to the grid when demand is high. The electricity prices tend to be high. High altitude wind power. Energy can be captured from wind by kites, aerostats, airfoils, metric balloons, blade turbines, kite-tooms. The term high altitude wind power has been used to refer AWE system, which is air and borne wind energy. However, semantically, HAWP might also include wind energy conversion systems that are somehow positioned at large height from the ground or sea surface. Hydroelectricity. Hydroelectricity or hydroelectric power is the electricity generated from hydropower, water power. Hydropower supplies 1/6 of the world electricity, almost 4,500 TWh in 2020, which is more than all the renewable sources combined and also more than nuclear power. Hydropower can provide large amounts of low carbon electricity on demand, making it a key element for creating secure and clean electrical supply system. A hydroelectric power station that has a dam and reservoir is a flexible source, since the amount of electricity produced can be increased or decreased in seconds or minutes in response to varying electrical demands. Once the hydroelectric complex is constructed, it produces no direct waste and almost always emit considerable less greenhouse gas than fossil fuel powered energy plants. However, when constructed in lowland rainforest areas where the part of forest is inundated, substantial amount of greenhouse gases may be emitted. Hydrogen economy. The hydrogen economy uses hydrogen to decarbonize economic sectors which are hard to electrify. Essentially, the hard to abate sectors such as cement, steel, long haul transport, etc., in order to phase out fossil fuel and limit climate change. Hydrogen can be created from water using renewable resources such as wind and solar, and its combustion only releases water vapor into the atmosphere. Hydrogen storage. Underground hydrogen storage. Several methods exist for storing hydrogen. These include mechanical approaches such as using high pressure and low temperature, or employing chemical compounds that releases hydrogen upon demand. While large amounts of hydrogen are produced by various industry, it is mostly consumed at the site of production. Notably, for the synthesis of ammonia, this is used. For many years, hydrogen has been stored as compressed gas or cryogenic liquid and transported as such in cylinders, tubes, and cryogenic tanks, or used in industry or as propellant in space programs. Interest in using hydrogen for onboard storage of energy in zero emissions vehicles is motivating, and development of new method of storage more adapted to this new application. The overarching challenges is the low boiling point of hydrogen. It boils around minus 252 degrees centigrade. Achieving such low temperature requires spending significant energy. Hydropower. Energy from moving water. Hydropower, also known as water power, is the use of falling or fast running water to produce electricity or to power machine. This is achieved by converting the gravitational potential or kinetic energy of water source to produce power. Hydropower is a method of sustainable energy production. Hydropower is now used principally for hydroelectric power generation, and is also applied as one half of energy storage system known as pumped storage hydroelectricity. Hydropower is an attractive alternative to fossil fuel as it depend or as it does not directly produce carbon dioxide or other atmospheric pollutant, and it provides a relatively consistent source of power. Hydro uh, Hygroelectricity. Hygroelectricity is a type of static electricity that forms on water droplets and can be transferred from droplets to the small dust particles. The phenomena is commonly in the Earth's atmosphere but has also been observed in steam escaping from boilers. It was basis proposal by Nikola Tesla to tap electricity from air, an idea which has been recently revived. Hygroelectric charge is the likely source of electric charge which under certain conditions. Implosion. Implosion is a process in which objects are destroyed by collapsing or being squeezed on themselves, opposite of explosion. Kaplan turbine. Kaplan turbine is a propeller type Kaplan turbine which has adjustable blades. It was developed in 1913 by Austrian professor Victor Kaplan, who combined automatically adjusted propeller blade with automatically adjusted wicket gates to achieve efficiency over wide range of flow of water. Light crude oil. Light crude oil is a liquid petroleum that has low density and flow freely from at room temperature. It has a low viscosity, low specific gravity and high API gravity due to the presence of high proportion of light hydrocarbon fractions. It generally has a low wax content. Light crude oil receives an higher price than heavy crude oil or commodity markets because it produces a higher percentage of gasoline and diesel fuel when converted into products by an oil refinery. Liquid fuels. Liquid fuels are combustible or energy generating molecules that can be harnessed to create mechanical energy, usually producing kinetic energy. They also must take the shape of their container. It is the fumes of liquid fuels that are flammable. Instead of fluid, mostly liquid fuels is widespread used are derivatives and derived from fossil fuels. However, there are several types of such hydrogen fuels. Ethanol and biodiesel which are also categorized as liquid fuels. Many liquid fuels play a primary role in transportation and the economy. Liquid fuels are contrasted with solid fuels and gaseous fuels. Liquid nitrogen engine. A liquid nitrogen engine is used in liquid nitrogen vehicle which is powered by liquid nitrogen which is stored in tank. Traditional high nitrogen engine design work by heating the liquid nitrogen in a heat exchanger, extracting heat from the ambient air and using the resulting pressurized gas to operate a piston or rotary motor. Vehicles propelled by liquid nitrogen have been demonstrated but are not used commercially. One such vehicle, Liquid Air, was demonstrated in 1902. Marine current power. Marine current can be large amount of water largely driven by tides, which are a consequence of gravitational effects of the planetary motion of Earth, Moon and Sun. Methane clathrate. Methane clathrate. This is also called methane hydrate, hydromethane, methane ice, fire ice, natural gas hydrate or gas hydrate is a solid clathrate compound, more specifically a clathrate hydrate. in which large amount of methane is trapped within the crystal structure of water, forming a solid similar to ice. Methanol. Methanol, also known as methyl alcohol or wood spirit, amongst other names, is an organic chemical and a simplest aliphatic alcohol. Today, methanol is mainly produced industrially by hydrogenation of carbon monoxide. Methanol economy. The methanol economy suggested future economy in which methanol and dimethyl ether replaces fossil fuel as a means of energy storage, ground transportation fuel, and raw material for synthetic carbon and their products. It offers an alternative to the proposed hydrogen economy or ethanol economy. Although these concepts are not exclusive, methanol can be produced from a wide variety of sources including fossil fuel, natural gas, coal, oil shale, tar sand, as well as agricultural products and municipal waste. Natural gas. Natural gas, also called fossil gas, methane gas, or simply gas, is a naturally occurring mixture of gaseous hydrocarbons consisting of primarily of methane, in addition to various smaller amounts of other higher alkalines. Low levels of traces gases like carbon dioxide, nitrogen, hydrogen sulfide, and helium are also present. Methane is colorless and odorless and the second largest greenhouse gas contributor to the global climate change after carbon dioxide. Because natural gas is odorless, odorizers such as mercaptan, which smells like sulfur or rotten eggs, are commonly added to it for safety so that any leaks can be detected. Natural gas fields. Natural gas vehicles as an alternative fuel vehicle that uses compressed natural gas or liquefied natural gas comes from natural gas field. Natural gas originates by the same geological thermal cracking process that convert kerogen to petroleum. As a consequence, oil and natural gas are often found together in common usage. Deposits rich in oil are known as oil fields, and deposits rich in natural gas are called natural gas fields. Natural gas. Nuclear energy. Energy in the nucleus or core of atoms are called nuclear energy. Nuclear fusion is a reaction in which two or more atomic nuclei, usually deuterium and tritium hydrogen variants, combine to form one or more different atomic nuclei and subatomic particles, neutrons or protons. The difference in mass between reactants and products is manifested as either the release or absorption of energy. The difference in the mass arises due to difference in nuclear binding energy between atomic nuclei before and after reaction. Nuclear fusion is the process that powers active or main sequence stars and other high magnitude stars where large amount of energy is released. Nuclear fusion is a reaction in which two or more atomic nuclei, usually deuterium and tritium, combine. Nuclear reactors. A nuclear reactor is a device used to initiate and control fission nuclear chain reaction. Nuclear reactors are used at nuclear power plants for electricity generation and nuclear marine propulsion. Heat from nuclear fission is passed to the working fluid, water or gas, which in turn runs through steam turbines. These either drive a ship's propellers or turn electrical generator shafts. Nuclear generated steams in principle can be used for industrial process heat or district heatings. Some reactors are used to produce isotopes or medical and industrial use. International Atomic Energy Agency reports that 422 nuclear power reactors and 223 nuclear research reactors are operating around the world. Nuclear reprocessing. Nuclear reprocessing is the chemical separation of fission products and actinides from spent nuclear fuel. Oil drilling. An oil well is a drilled hole boring in earth that is designed to bring petroleum or hydrocarbons to the surface. Usually, some natural gas is released as associated petroleum gas along with the oil. A well that is designed to produce only gas may be termed as gas well. Wells are created by drilling down into oil gas reserves that is then mounted with the extraction device such as pump jacks, which allows extraction from the reserves. Creating the wells can be a very expensive process, costing at least hundreds of thousands of dollars and costing much more than when it hard to reach areas when creating offshore oil platform. Oil platforms. An oil platform, also called oil rig, offshore platform, oil production platform, is a large structure with facilities to extract and process petroleum and natural gas that lie in a rock formation beneath the seabed. Many oil platforms will also have facility of accommodation and workers, although it is also common to have separate accommodation platform bridge linked to the production platform. Most commonly, oil platforms engage in activities of continental shelves, though they can also be used in lakes, inshore waters, inland seas. Depending on the circumstances, the platform may be fixed to the ocean floor, consists of artificial island or float. In some arrangements, the main facility may have storage facility for the processed oil. Remote subsea wells may also see connected to the platform by flow lines. Oil refinery. An oil refinery or petroleum refinery is an industrial process plant where petroleum crude oil is transformed into refined into useful products such as gasoline, diesel fuel, asphalt, petrol, base fuel oils, heating oil, kerosene, liquid petroleum gas, and petroleum naphtha. Petrochemical feedstock like ethylene and propylene can also be produced directly by cracking crude oil without the need of using refined product of crude oil such as naphtha. The crude oil feedstock has typically been processed by an oil production plant. There is usually oil depot at the near of oil refinery for the storage of incoming crude oil. Feedstock as well as bulk liquid products. In 2020, total capacity of global refineries for crude oil was about 101.2 million barrels per day. Oil shale. Oil shale is an organic rich, fine-grained sedimentary rock containing kerogen, a solid mixture of organic chemical compound from which liquid hydrocarbons can be produced. In addition to kerogen, general composition of oil shales constitutes inorganic substance and bitumens based on their deposition environment. Oil shales are classified as marine, lacustrine, or terrestrial oil shale. Oil shales differ from oil-bearing shales. Shale deposit that contains petroleum, light oil that are sometimes produced from drilling well. Example of oil-bearing shales are at Bakken Formation and many other places. According to the shale oil produced from oil shale should not be confused with light oil, which is also frequently called shale oil. Oil well. An oil well is a drill hole boring in earth that is designed to bring petroleum oil hydrocarbons to the surface. Osmotic power or salinity gradient power. It is energy available from difference in the salt concentration between seawater and river water. OTC, Ocean Thermal Energy Conversion. This uses ocean thermal gradient between cooler deep and warmer shallow of surface seawaters to run a heat engine and produce useful work. Usually in the form of electricity, OTC can operate with a very high capacity factor and so can operate in base load mode. Oxidation, reduction, oxidation is a type of chemical reaction in which the oxidation states or substrate changes. Oxidation is the loss of electrons or an increase in the oxidation state. while reduction is a gain of electron or decrease in oxidation state. Peat. Peat is an accumulation of partially decayed vegetation or organic matter. It is unique to nature, called peatlands, bogs, mires, moors or muskeggs, etc. Also called peat moss, is one of the most common components in peat. Petroleum, also known as crude oil or simply oil, is a naturally occurring yellowish black liquid mixture of mainly hydrocarbons and is found in geological formation. Petroleum is primarily recovered from oil drilling. Photovoltaic. Photovoltaics is a conversion of light into electricity using semiconducting material that exhibits photovoltaic effect. A phenomenon studied in physics, photochemistry and electrochemistry. The photovoltaic effect is commonly used for electricity generation as photosensors. Photovoltaic system employs solar modules, each comprising a number of solar cells, which generate electrical power. Piezoelectricity. Piezoelectricity is the electricity charge that accumulates in certain solid materials such as crystals, certain ceramics and biological matter such as bone, DNA and various proteins in response to applied mechanical stress. It is derived from ancient Greek word. A piezoelectric effect results from the linear electromechanical interaction between the mechanical and electrical states in crystalline material with no inversion symmetry. The piezoelectric effect is a reversible process. Materials exhibit the piezoelectric effect also exhibit the reverse piezoelectric effect. The internal generation of the mechanical strain results from an applied electric field. Pneumatics is a branch of engineering that makes use of gas or pressurized air. Petroleum products are mainly derived from crude petroleum. Propellant. Propellant is a mass that is expelled or expanded in such a way as to create a thrust on another motive force in accordance with Newton's third law of motion and propel the vehicle, projectile or fluid payload in vehicles. Pyrolysis. The pyrolysis process is a thermal decomposition of materials at elevated temperature, often in an inert atmosphere. Temperature can be understood as thermal vibration. A high temperature, excessive vibration causes long chain molecules to break into similar molecules. Renewable energy. Renewable energy is energy from renewable resources that are naturally replenished on human time scale. Renewable energy sources include sunlight, wind and movement of water and geothermal heat. Although the most renewable sources are sustainable, some are not. For example, some biomass sources are considered unsustainable at current rates of exploitation. Renewable energy is often used for electricity generation, heating and cooling. Renewable energy projects are typically large scale, but they are also suited to rural and remote areas and developing countries where energy is often crucial to human. Small hydro. Small hydro is a development of hydroelectric power on the suitable scale for local community and in very small scale. So it mini small hydro project is of 1 megawatt power, smaller than 1 megawatt power, and micro small hydro project is smaller than 100 kilowatt, and pico small hydro water project is smaller than 10 kilowatt. In contrast, many hydroelectric projects are enormous size. In hydroelectric projects are of enormous size, such as generating plants at the Three Gorges Dam at 22,500 megawatt, or the vast multiple project of Tennessee Valley Authority. Solar cooker box. A solar cooker is a device which uses energy of direct sunlight to heat, cook or pasteurize drinks and other food material. Many solar cookers currently in use are relatively inexpensive, low-tech Solar cells. A solar cell or photovoltaic cell is an electronic device that converts energy of light directly into electricity by photovoltaic cell, which is physical phenomena. It is a form of photoelectric cell defined as a device whose electrical characteristics such as current, voltage, resistance vary when exposed to light. Solar chimney. A solar chimney, often referred to as thermal chimney, is a way of improving the natural ventilation of building. A solar chimney has been used for centuries. Solar panel. Photovoltaic PV is the conversion of light into electricity using semiconducting material that exhibits photovoltaic effect, a phenomena studied by physical photochemistry. The photovoltaic effect is commonly used for electricity generation and photosynthesis. Solar energy. Solar energy is a radiant light and heat from sun that is harnessed using a range of technologies such as solar power to generate electricity, solar thermal energy including solar heat and solar architecture. It is essentially source of renewable energy and its technology and are broadly characterized as either passive solar or active solar depending on how they capture and distribute solar energy. Solar power satellite. Space-based solar power is a concept of collecting solar power in outer space with solar power satellites. Solar thermal energy is a form of energy and a technology for harnessing solar energy to generate thermal energy for use in industry and residential and commercial sector. Solar water heating. Solar water heating is a heating water system using sunlight using solar thermal collector. A variety of conversion are available. Solid fuel. Solid fuel refers to various forms of solid material that can be burned to release energy, providing heat and light through the process of combustion. Solid fuels can be contrasted with liquid fuel and gaseous. Common examples of solid fuels are wood, charcoal, peat, coal, hexamine fuel tablets, dry wood, etc. Steam turbine. A steam turbine is a machine that extracts thermal energy from pressurized steams and uses it to do mechanical work in rotating output shaft, its modern manifestation. Straight vegetable oil. Vegetable oil can be used as an alternative fuel in diesel engines and heating oil burners. Syn fuels. Synthetic fuel or syn fuel is a liquid fuel or sometimes gaseous fuel obtained from syngas, a mixture of carbon monoxide and hydrogen, in which the syngas was derived from gasification of solid feedstocks such as coal, biomass, or by reforming of natural gas. Syngas. Syngas or synthetic gas is a mixture of hydrogen and carbon monoxide in various ratios. The gas often contains some carbon dioxide and methane. It is principally used for producing ammonia and methanol. Syngas is combustible and can be used as a fuel. Tar sand. Oil sands, tar sands, crude, bitumen or bituminous sand are the type of unconventional petroleum deposits. Oil sands are either loose sands or partially consolidated sand soil, contain naturally occurring mixture of sand, clay and water soaked with bitumen. Thermal power station. A thermal power station is a type of power station in which heat energy is converted into electrical energy. In a steam generating cycle, heat is used to boil water in a large pressure vessels to produce high pressure steam, which derives a steam turbine connected to electrical generators. The low pressure exhaust from the turbine enters the steam condenser, where there is a cool to produce hot condensate, which is recycled to a heating process to generate more high pressure steam. Thorium. Thorium is a weakly radioactive metallic chemical element with the symbol Th and atomic number 90. Thorium is light silver and tarnished olive grey when it is exposed to air, forming thorium oxide. It is moderately soft and malleable and has a high melting point. Thorium is an electropositive actinide whose chemistry is dominated by +4 oxidation state. Tidal power. Tidal power or tidal energy is harnessed by converting energy from tides into useful form at power, mainly electricity, using various methods. Nuclear transmission or nuclear transmutation is a conversion of one chemical element or isotope into another chemical element. Uranium. Uranium is a chemical element with symbol U and atomic number 92. It is silvery grey metal in the actinide series of the periodic table. The uranium atom has 92 protons and 92 electrons, of which 6 are valence electrons. Uranium has highest atomic weight in the periodic table. Its density is about 70% higher than the lead and is used in nuclear reactions. Vacuum energy. Vacuum energy is underlying background energy that exists in space through the entire universe. The vacuum energy is a special case of zero-point energy that releases the quantum vacuum. Water turbine. A water turbine is a rotatory machine that converts kinetic energy and potential energy of water into mechanical energy. Wave power. Wave power is the capture of energy of wind waves to do useful work. For example, electricity generation, water desalination, and pumping water. A machine that exploits wave power is a wave energy converter. Wind energy. Wind power is the use of wind energy to generate useful work. Historically, wind power used by sails, windmills, and wind pumps. But today, it is mostly used to generate electricity. This article deals only with wind power for electricity generation. Today, wind power is generated almost completely with wind turbines, generally grouped into wind farms and connected to the electrical grid. Wind energy has become very significant because in production of green energy it is very useful and most important type of energy that can be used to produce green energy. In 2022, wind supplied over 2000 TWh of electricity, which was over 7% of world electricity and about 2% of world energy. With about 100 gigawatt added during 2021, mostly in China and United States, globally installed wind power capacity exceeds 800 gigawatt. Wind farm. A wind farm or wind park, also called wind power station or wind power plant, is a group of wind turbines in the same location used to produce electricity. Wind turbines. A wind turbine is a device that converts kinetic energy of wind into electrical energy. As of 2020, hundreds of thousands of large turbines is installed in installations known as wind farms, were generating over 650 gigawatt of power, with 60 gigawatt added each year. Wood fuel. Wood fuel is a fuel that is firewood, charcoal, chips, sheets, pellets. Wood gas. Wood gas is the fuel gas that can be used for furnace, stove, and vehicle. So, this was complete details of all type of energy that we can use today. Thank you.